Welcome back, deep divers. We're going way back in time today.
Way back.
Back to the Stone Age.
Okay.
But not just any old part of the Stone Age.
All right.
This is between 14,000 and 11,600 years ago.
Okay.
A period called the Final Paleolithic in Europe.
Gotcha.
And this wasn't just like a slow, gradual kind of change in how people were living. It was like upheaval central.
Oh, yeah. I mean, the Final Paleolithic, it really throws a wrench in the works if you think the Paleolithic was just one long, static period.
Right.
It's like the grand finale.
Yeah.
Everything's changing rapidly.
Exactly.
And societies are having to really, really adapt.
Yeah, and we have a great study that's going to help us really get into the nitty-gritty.
Okay.
It's from 2025, published in PLOS One. It's called Large-Scale and Regional Demographic Responses to Climatic Changes in Europe During the Final Paleolithic.
Catchy title.
Yeah.
I like it.
And what's really cool about this is they use data from archaeological sites all over Europe, and then they have this really smart way of using that data to estimate how many people are actually living in different parts of Europe.
Right.
And how densely populated.
Population density. It's a whole other way of looking at it than just like, oh, here's a site. Here's a site.
Right. So it's not just like a head count of artifacts or something.
Exactly, yeah.
Yeah.
It's like taking into account the space between these sites and how they're distributed and things like that.
Exactly. And the method they use for this, it's called the Cologne Protocol.
Okay.
Yeah.
The Cologne Protocol. It's a powerful tool for kind of reconstructing those ancient demographics.
So for you listening in,
Yeah.
we're going to try and figure out how these huge climate swings going on at the time really had an impact on early humans in Europe.
Okay.
And you might be surprised at what we find out about where people lived, how they moved around, and how really these ancient shifts might just totally change how you think about this period.
Yeah, it challenges a lot of assumptions, that's for sure.
Yeah. So let's zoom out a little bit and just set the scene. Okay.
Yeah.
So what was Europe even like when all of this kicked off? What was the landscape like?
So we're talking about the tail end of the last ice age. We call this period the late glacial.
Okay.
And specifically, two key phases called Greenland Interstadial 1 and Greenland Stadial 1, or GI1 and GS1 for short.
Okay.
Now, these were like warmer and colder periods within that overall late glacial context.
Gotcha.
And what happened was essentially like a rapid environmental transformation, right? It's not a gradual thing. It's fast.
Yeah.
And we see the spread of shrubs and trees across northern, western, and central Europe. So imagine it, like the environment's changing rapidly. There's a lot more vegetation than there used to be.
Okay, so that classic image we have of like the mammoth steppe.
Right, the mammoth steppe.
With all the like, the woolly mammoths and all these big animals.
Yeah, and wide open spaces.
Yeah, is that like gone by this point?
It's on its way out. I mean, it wasn't ever completely uniform, right? But this period marks a shift to a much more diverse environment.
Right.
From region to region. It's like a mosaic.
A mosaic. Okay.
Different ecological zones. Very different from the more uniform landscapes of those, peak ice age times.
So it's not just about, colder or warmer. It's about what that's doing to, like, the plants and the animals.
Absolutely. And, of course, to the humans living there.
Right. So this environmental shift, this big mosaic appearing, this all happens around the time that we have the late Upper Paleolithic transitioning to the Final Paleolithic.
Exactly. It's not just about the physical landscape changing. Human societies are changing, too.
Right.
They're having to adapt to these new conditions.
Yeah, and it's not just about the environment, right? Like, how are people actually changing how they're living?
So we see some really interesting shifts in hunter-gatherer strategies. They're relying less on those big migratory game, the classic ice age animals, and more on like a stationary game, animals that are kind of sticking around in one area.
Okay, interesting.
Also, their campsites are changing. We start to see evidence of like functionally differentiated sites.
Functionally differentiated, so like specialized sites.
Exactly. So instead of just one big campsite where everything's happening, we're seeing maybe sites specifically for hunting.
Okay.
Maybe sites specifically for processing food, that kind of thing.
So almost like early, like specialized workplaces in a way.
Yeah, you could think of it like that.
Okay.
And their tools are changing too. The way they make stone tools, their lithic technology.
Yeah.
It's becoming less standardized.
Yeah.
In the Upper Paleolithic, we see a lot of really, really standardized tool types that are found over very wide areas. But in the Final Paleolithic, we see a lot more regional variation.
Okay.
Especially in things like projectile points.
Okay.
Like the shape of their spear points is becoming much more regionalized.
So they're not just like following one recipe for how to make a good spear point anymore. They're kind of
innovating.
Yeah.
Yeah, exactly.
Yeah.
Experimenting. And even their art changes, right?
Yeah.
We see a move away from those grand cave paintings of the Upper Paleolithic to more abstract designs on smaller objects, pebbles, and things like that.
So it's like a whole package of things are shifting at once.
Yeah. It's this really, really fascinating period of change and adaptation.
Okay. And the study points out something really interesting, that the traditional kind of demographic centers that we think of for the earlier period, like the Franco-Cantabrian region, so like southwestern France and northern Spain,
right,
and eastern central Europe, they lose importance during the Final Paleolithic.
You do, yeah. There's a definite shift in the balance of where people are living across the continent.
So what's going on? Like, what do they think is causing that?
Well, it suggests that, there are these underlying forces at play, maybe even migration patterns that are causing people to move around or certain areas to become more important than others.
Okay. So this is where the research really comes in.
Exactly.
Like, how did they figure this out? What is this Cologne Protocol thing? Tell us more about it.
Okay, so they've got this incredibly detailed database. They've assembled data from 1,788 final Paleolithic sites.
Wow.
Across southern, western, northern, and central Europe.
1,788 sites.
It's a massive amount of information.
Just gathering that together must have been a huge task.
Oh, absolutely, yeah. It's a testament to the work of archaeologists over decades.
Right.
But then they take that database and they apply the Cologne Protocol, which, remember, is this way of using the spatial information to estimate population size.
Okay.
And they focus their analysis on two main time periods.
Okay.
Corresponding to those climate phases we talked about.
Yeah.
GI1DA, which is from 14,000 to 12,700 years ago, and GS1, which is from 12,700 to 11,600 years ago.
So they're like taking a snapshot of the population at those 2 points in time.
Yeah.
And they're comparing them.
Yeah, exactly. Warmer versus colder, essentially.
Right.
And to make things even more robust, they actually use two different data sets.
Right. Okay.
So data set A includes all 1,788 sites.
Okay.
Even some where the dating might not be super precise.
Gotcha.
And then dataset B only includes sites with very clear chronological assignments.
So that accounts for, like, some areas might have better dating than other areas.
Yeah. Archaeological data is never perfect. There's always regional variation.
Right, of course.
And so using these two data sets allows them to kind of account for that a bit.
Makes sense. So what about these raw material catchment areas that they mentioned in the study?
Yeah, the RMCAs. This is a really important part of their analysis.
Okay.
So they look at the typical area from which people were getting their raw materials, like flint, for making tools. And the idea is, if people are getting their raw materials from a relatively small area, it might suggest a higher population density.
Okay.
Because they don't need to travel as far to get the stuff they need.
So, like, if everybody's getting their flint from, like, a 10-mile radius,
right,
it means there's probably a lot of people.
Yeah, there's a lot of people in that area who are all using that same resource.
Right. And they don't have to, like, walk for days to get there.
Exactly.
Okay.
And then, to get to actual population estimates, they combine this information with, like, the size of what they call core areas, which are regions that show a high concentration of hunter-gatherer activity.
Right.
And they also look at estimates of average group size from modern hunter-gatherer societies.
So they're looking at, like, what we know about modern hunter-gatherers and using that.
Exactly. It's called ethnohistoric data.
Okay.
And it's a way of kind of using modern analogs to understand the past a little bit better.
Okay. So they're putting together these different lines of evidence, like the number of sites,
right,
the raw material stuff,
yeah,
like the ethnohistory stuff about group sizes.
It's all coming together to paint this picture.
Yeah. So with all of that in mind, what did they actually find out? Like, what were some of the big shifts they saw?
Well, one of the most striking findings is this large-scale shift northward.
Okay.
For the first time since modern humans arrived in Europe, tens of thousands of years earlier, we see the areas north of the Alps becoming the dominant zone for population growth.
Really?
Yeah. It's a really big change from, like, the Upper Paleolithic, where we see those traditional centers in the south and east.
So it's not just that they stayed the same, it's that it flipped.
It flipped. It really did.
Okay.
And during that warmer GI1DA period, they estimate the total population to be around 8,100 people.
Okay.
based on dataset A, or around 5,700 based on dataset B, that more precisely dated one.
So it was still relatively small, even though it was growing.
Oh, absolutely, yeah. Very small compared to today's standards.
Yeah.
But then things get really interesting when we get to the colder GS1 period, because we see a very significant population decline.
Okay.
The estimates drop to around 4,250 in dataset A and 3,500 in dataset B.
So, like, almost cut in half?
Yeah, roughly a 50% reduction.
Wow, that's huge.
It is huge. And it would have a massive impact on those communities.
Yeah, not just on the, like, number of people,
Right.
but on their...
The way they lived, the way they interacted.
Yeah.
Yeah, absolutely.
And it wasn't just the total number, right?
Right.
The density of people in those core areas also went down.
It did, yeah. So fewer people spread out over a wider area, generally speaking.
Fewer people, more spread out. But the study also pointed out, like, some really interesting regional variations.
Yeah, absolutely. It's not just this simple story of decline everywhere.
Right.
There's a lot more nuance to it.
Right.
One of the most noticeable things is this apparent lack of archaeological sites in a kind of band stretching from southwest to northeast across central France and Germany.
Okay.
It's like this demographic void.
A void. So, like, they just disappeared.
Well, it's a point of debate, right? It could be a real phenomenon, people actually abandoning those areas.
Right.
But it could also be due to gaps in the archaeological record.
Right.
Maybe less research has been done in those regions, or maybe the conditions for preservation weren't as good.
Gotcha.
But what makes it really intriguing is that this void actually seems to have expanded compared to the Magdalenian period, which came just before.
So it's not just like we haven't found the stuff.
It suggests that something more might be going on.
Right. So what about the areas that bucked the trend? Like, where did things get interesting?
So the Czech Republic and southeastern Germany actually had the largest and densest populations during GI1DA.
Okay.
But they also experienced the strongest decline during GS1.
So like boom and bust.
Boom and bust, exactly. Now, in contrast, Poland and northeastern Germany actually show a population increase.
Really?
Yeah.
During the colder period?
During GS1, yeah.
Wow. Why would they increase when everybody else is declining?
That's a great question. And it likely has to do with the fact that climate change wasn't having a uniform impact everywhere.
Right.
And northeastern Italy also showed a population increase during the colder period.
Okay.
Southern Scandinavia, on the other hand, experiences this really sharp decline during GS1, almost a complete abandonment.
Wow.
And then Switzerland and southwestern Germany showed relatively stable populations, at least in dataset B.
Okay. So it's like a patchwork.
It is a patchwork, yeah.
Some places are booming, some places are busting, some places are just staying the same.
And it all points to the fact that climate change was this massive driving force behind everything.
Right. So how did they tie all this, like all these population shifts specifically to climate change? Like, how do we know that's the main cause?
Well, they find a strong correlation between the cooling of GS1, also known as the Younger Dryas, and that widespread population decline.
It's okay.
And this isn't the first time we've seen this kind of thing in prehistory.
Okay.
You know, the similar pattern of decline is observed during the late Gravitian, which was also a colder phase.
Okay, so cold equals.
Yeah, generally colder temperatures seem to put a strain on these early populations.
Yeah, but you mentioned earlier that, like, unlike the Gravitian, some areas actually saw an increase in population density during this colder period. So it's not just a simple decline.
Exactly. And the researchers suggest that that increase in parts of Central Europe during GS1 likely represents eastward movements.
Okay.
So as conditions worsened in some regions, particularly those in the West that were more severely affected by the Younger Dryas cooling, people might have been migrating eastward towards areas with more favorable conditions.
So climate change is like pushing people around the map.
It is. It's like reshaping the demographics of Europe.
Yeah.
And it's important to remember that the Younger Dryas didn't have a uniform impact.
Right.
There was a general trend of more severe cold and dry conditions in the West compared to the East.
So the West is getting hit harder.
Yeah.
People are moving east.
Exactly. And that actually lines up with the observed eastward shift in those core areas of population in Northern and Central Europe during GS1.
Okay.
And we even have other evidence, like isotope analysis of reindeer teeth from Northern Germany, that suggests these animals were also migrating east-west during the Younger Dryas.
Right.
Which would definitely impact the humans who were hunting them.
Yeah, for sure, for sure.
So there's this kind of like ripple effect going on through the ecosystem.
Okay. And then there's another element that gets mentioned, which is this Lager Sea volcanic eruption.
Yes, the Lager Sea eruption.
Yeah.
This was a massive event.
Okay.
It happened around 13,000 years ago, right at the end of GI-1b.
Right before.
Yeah, right before the Younger Dryas. And the study points out this interesting geographic overlap between that demographic void in Central Europe and the area that would have received significant ashfall from the eruption.
So, could that have caused people to just, abandon that region?
It's certainly possible. I mean, imagine a massive volcanic eruption.
Yeah.
Spewing ash all over the place. That would have immediate and longer-term impacts on the environment.
Would have made it really hard to live there.
Exactly.
Yeah.
And there's even stratigraphic evidence from some sites that suggests the ashfall might have directly ended the occupation by certain groups, like the Federmessergruppen in some areas.
Wow.
So it could have added significant stress to those populations even before the full force of the Younger Dryas hit.
So it's like a 1-2 punch.
Yeah.
Volcano and then cold.
Exactly.
Wow.
Not a good time to be living in Central Europe, probably.
No. So all of this makes me wonder about, how small were these populations actually getting? Were they in danger of just disappearing entirely?
That's a really important question. And the study touches on this idea of a minimal viable population.
Okay.
Which is the smallest number of individuals needed for a population to survive in a long term.
Right.
And interestingly, the estimated population sizes for Europe as a whole, even during that GS1 decline, they generally stayed within the range as considered minimally viable.
Okay.
Although, again, those regional drops were significant.
Right.
It's hard to put an exact number on it.
Yeah.
Because it depends on so many factors.
Of course.
But a common lower limit is around 1,500 individuals.
Okay.
To avoid those immediate risks of inbreeding.
Okay.
But even if you're above that threshold,
yeah,
very small populations are still incredibly vulnerable to any kind of random event.
Right. Disease, natural disaster.
Exactly. One bad winter could wipe out a significant portion of the population.
Yeah.
So even though Europe as a whole might have been okay, some individual regions might have been right on the edge.
Yeah, I see.
And a decline like this would have had a huge impact on social connections and networks.
Right. So if there's fewer people, those networks just shrink.
They shrink, yeah. And those connections, especially over long distances, would become much thinner.
Right.
Which is really interesting because on the one hand, you might think, okay, well, if there are fewer people, you need to cooperate more.
Right.
But if those networks are shrinking, it might actually make it harder to cooperate.
Yeah, I see.
So it's a really complex dynamic.
Right.
And the study also found an increase in the size of those raw material catchment areas.
Okay.
During the Final Paleolithic in most of Europe, except the Northwest.
Okay.
So this suggests that people were having to travel farther to get essential resources.
Right. So does that mean they were more spread out?
It could mean that. Yeah.
Or that they needed to, trade more with other groups.
Exactly. Maybe they had to rely more on exchange network to get the stuff they needed.
Makes sense.
And interestingly, there's also less evidence for the long-distance transport of exotic goods.
Okay.
Like marine shells, which were more common in earlier periods.
Yes, right.
So this might suggest a reduction in those really, really long-range connections.
Okay.
And that void we talked about could also be a reflection of that.
So less stuff moving around means less people connecting.
Yeah. It's like the world is becoming a little bit smaller, at least in terms of those long-distance interactions.
Yeah.
And there's some interesting genetic evidence, too.
Okay.
Paleokinetic data suggests potential movements of people from south to north.
Okay.
During GI-1DA.
Okay.
And then greater genetic continuity within Iberia.
Okay, so Iberia is
That's like its own little world during this period.
Okay.
Relatively isolated.
Right.
Which makes sense given what we know about the archaeology and the environment.
Yeah. So all these different lines of evidence, archaeology, the resources, the genetics, it all points to this. It's a complex picture of how people were moving and connecting.
And changing during
this period.
Absolutely.
Okay, so let's try to summarize this. What are the key takeaways? What should we really remember from all of this?
Okay, so the big picture is this. The Final Paleolithic was a period of massive demographic upheaval in Europe, driven primarily by climate change.
Right.
Now, there was an overall population decline during the Younger Dryas, but the regional responses were incredibly varied.
Right.
We see a shift eastward in northern and parts of Central Europe, which is really different from what we see in Iberia and southwestern France, where there were more localized declines. And then we've got that demographic void in Central Europe, possibly linked to both climate and the Lechercy eruption.
Right. So what's like the aha moment for all of us listening? Like, what's the big takeaway?
I think the aha moment is just how clearly this research demonstrates the link between climate change, even thousands of years ago, and massive changes in human populations and societies. It's a powerful parallel to what we're facing today.
Right.
And understanding how these past populations responded can teach us a lot about human resilience and adaptation.
Yeah. And so to leave you with something to think about, we've talked about all these migrations and how climate change is pushing people around. What are some other things that might make people decide to move or to stay put beyond just the immediate climate stuff?
Like social factors, technological innovations, maybe even just personal choices.
Right.
I mean, there's so many things that could influence a decision like that.
Yeah. And what are some parallels we see today as we face our own rapid environmental changes?
Are we going to see similar migrations? Are people going to stay put? What are the factors that are going to influence those decisions?
How much control do we actually have over those decisions, both individually and as a society?
It's a huge question.
Yeah.
With no easy answers.
It makes you think.
It is.
So if you want to learn more about all of this, we encourage you to check out the full article.
Absolutely.
It's got a ton more detail on the methodology and all the regional data.
Yeah. There's so much to explore.
Yeah. Until our next deep dive.
Happy diving.
Keep those questions coming.